Hello everyone, welcome to your first lesson. So we are going to start by solving systems of equations with graphing. So this is going to be a review of Algebra 1 stuff. So our very first problem up here, we have the equations y equals negative 3x plus 4 and y equals 3x minus 2. So what we want to do is we want to graph those and we want to find their intersection, and their intersection is going to be our solution. So before we graph it, we want to be sure that our equations are in slope-intercept form. Just to remind you, slope-intercept form is y equals mx plus b. M is our slope and b is our y-intercept. So when our equations are already in slope-intercept form, as our first two equations are, we are going to begin with b, move like m. So we're going to begin with the y-intercept. So looking at my first equation, my m is going to be the negative 3, my b is the 4. So begin with b, begin with 4. 4 is my y-intercept. I put it on the y-axis, which is the vertical axis. And then we're going to move like m. So when we look at slope, we have to have a rise over run. Right now my slope is just negative 3. So I'm going to turn it into a fraction by making it negative 3 over 1. And you can do that with any whole number. So now I know how much I'm going to rise and how much I'm going to run. So I'm going to begin here at my y-intercept, begin at b, and I'm going to rise negative 3. So instead of going up 3, I'm going to go down 3 spaces. And then I'm going to run 1. So it's a positive 1, I'm going to go to the right 1. And I'm going to plot my next point right there. I'm going to continue to go with that pattern, down 3, 1, 2, 3, over 1. And when I've made enough points, I can draw my line. Alright, now I need to tackle that second equation. So my m is 3, my b is negative 2. It's already in slope-intercept form, so I'm ready to start graphing. Begin with b. Begin with negative 2. That's your y-intercept. So on my y-axis, I go down to negative 2 and plot a point. So now my slope is going to be 3, so my rise over run is 3 over 1. So I'm going to rise 3, run 1. This time it's positive. So when I move, I'm going to begin here at my y-intercept. I'm going to rise up 3, 1, 2, 3, and to the right 1. I'm going to do it again. Go up 1, 2, 3, right 1. I could also do the complete opposite. I could start here at my y-intercept and I could do a double negative. Down 1, 2, 3, left 1. Those are both negative directions. Once I have enough points, I can draw my line. And there we go. I have both of my lines drawn for my two equations. Now all that's left to do is to write the solution. So my solution is where these two lines intersect, which is very clearly right there. So let me write the coordinates of it. X goes first, then y. So x is 1, y is 1. Well, okay, they're both the same numbers this time. 1, 1 is a solution to this system. Let's look at this next problem. Both of my equations are already in slope-intercept form, but that first one doesn't seem to have a b value at all. So I'm going to add that in there. I could add in the value of 0 and it won't change my equation. So now when I'm looking at that first equation, my m is 1 over 2, my b is 0. So let's begin with b. My y-intercept is 0, that's at the origin, so I can plot that point. My slope is 1 over 2, so I'm going to rise 1 and then run 2. Plot a point. Rise 1, run 2. I could also do the complete opposite. Down 1, left 2, the double negative, down 1, left 2. As long as you see that your line is rising from the left to the right, then you know you've made a positive slope. Okay, let's take a look at that second equation. My m is 1 over 2. My b is negative 3. Be sure you're always keeping the sign that's in front of the number, so that's a negative 3. So begin with B. Begin with your y-intercept at -3. And then I have that same slope, so I'm going to do the same pattern. Rise 1, run 2. Rise 1, run 2. You could also do the double negative, down 1, left 2, down 1, left 2. And draw your line, and I see my line goes up from left to right, so I know I made a positive slope. Now, what do y'all notice about these two lines? I'm supposed to find the intersection in order to find the solution, but there's no intersection on this graph. So before I decide what my answer is going to be, I needed to figure out if these two lines are ever going to intersect. So these two lines are parallel. They're never going to intersect. I know for certain that they are parallel because my slopes are the same. When your slopes are the same, you have a parallel lines. And my B values are different, so they're not on top of each other. They're parallel to each other. So if they're parallel, they never intersect. Therefore, my answer is no solution. There is no solution to the system of linear equations. Let's take a look at this final problem. We have 2x plus 3y equals 1, negative 4x minus 6y equals negative 2. I immediately notice that these are not in slope-intercept form. They don't look like y equals mx plus b. These are actually in standard form. So we are going to fix that. Over here on the side, I've rewritten them out, and we are going to get y by itself. So let me draw a line down the middle of the equal sign. I'm going to move the x to the other side first. Since that's a positive 2x, I will subtract 2x to both sides. Mark it out. Bring down the 3y equals. I'm going to put it in this order. So I cannot actually combine the 1 and the 2x because they're not like terms. One has an x, the other one doesn't. So I'm going to put the negative 2x first, and then plus 1 because it's positive 1. And the reason I did that is because I want it to look like y equals mx plus b, and you can see it's almost like it already, y equals mx plus b. It's just this 3 needs to move. So that's my final step. I'm going to divide by 3 everywhere. Mark it out. So then I get y equals negative 2 over 3x plus 1 over 3. All right, so let's go ahead and graph this one. I want to label my slope m, my y-intercept b. All right, let's begin with b. My y-intercept is 1/3. That's a little ugly, but we can do it. It would be about here, between 0 and 1. And then my slope is negative 2 over 3. So starting from that point, I'm going to go down 2 because it's negative 2. So down 1, 2, and then I'm going to go to the right 3. 1, 2, 3. So about right here. Okay, I can also do the opposite direction. I could start here and I could go up 1, 2, and then left 1, 2, 3. As long as when I look at my graph, my line is going down from left to right because it's a negative slope. All right, let's go ahead and get y by itself on this last problem. I'm going to add 4x to the other side. Mark it out. I have a negative 6y equals 4x minus 2. Be very careful on your signs. And then let's divide by negative 6. Be sure you divide it to every single term. Mark those out. We got y equals 4 doesn't divide by negative 6, but it does reduce. So let me write it over here so we can see it. What could I divide both of those numbers by? I divide them by 2. So that would give me 2 over negative 3. The negative, you can put it in the front of the fraction, you can put it on the top, you can put it on the bottom. It really doesn't matter as long as it's there. That has the x. And then negative 2 divided by negative 6 also doesn't divide, but they definitely have a number in common. Let's see what we could divide out. First of all, they're both negative, so I know it's going to be positive. And I could divide both of those also by 2. That gives me 1 over 3, and it's positive because it was negative divided by a negative. So what do you notice about the second equation here? My m again is negative 2/3. My b again is 1/3. So that would be the exact same line that I've already graphed. These two equations are the same. So when that happens, we have the same line, then technically if these are one line on top of another, then they are always intersecting. So we call that infinitely many solutions. All right, so these are the three things that can happen. You could have one solution, like our first problem, where the two lines intersect. We could have no solution because the two lines are parallel. And we could have infinitely many solutions because the two lines are the same.